Welcome back. Inscribed polygons are fully inside a circle except for the vertices of the polygon, which lie on the circle. So here we have an inscribed polygon, right? And we can see that our, there's a smudge on my board. All the vertices of this polygon are right on the circle. Every other part of that polygon is inside the circle. The only part that's on the circle are the vertices, and no part goes outside the circle. So that's what's called an inscribed polygon. It's written, so scribe means to write, right? So if you're a scribe, you're the person that's doing the writing, right? So we've written or drawn our polygon so that it's inside the circle. So we can describe the following picture, either the one we're just looking at or the one at the bottom there, except the one at the top here is a hexagon, or excuse me, a pentagon. We have five vertices. I'm thinking of my next slide. This one is a pentagon, right? So I could say the square or the pentagon, depending on which figure I want to look at, is inscribed inside the circle, right? So inscribed means that it's inside. Or the circle is circumscribed about the square, or the pentagon, depending on which one we wanted to look at. Whoops, we're missing a letter there. Let's put it over here. Right below, I'm just going to extend the page, and I don't want to do that. And circumscribed means outside. Like circumference, right? Circumference is outside the circle. Circumscribed is outside, right? So the circle is circumscribed about the square or pentagon. We're going to be constructing the inscribed regular hexagon, right? So regular means that all angles are congruent. And all sides are congruent. For our construction, we're going to be worrying about the sides, and in this case, because of our construction, that will ensure our angles are also congruent. All right, so let's go over the steps. You have these in your notes. If the picture, I think the words are okay, but the pictures might be a little light. Notice they're in blue. And you might want to darken them because you can see them up here. So we start with a given circle, or you may be asked to draw a circle, right? If you're given the circle, I'll give you the center. If you're drawing the circle, just make sure you push down hard enough when you draw the circle at the center there, so you can see where your center is, right? So all you got to do is, make sure your pointy part of the compass makes a mark, and it usually does, so it's usually not a problem. All right, so you're going to mark anywhere on the circle. This is going to be your first vertex of your hexagon. Doesn't matter where it is, all right? It won't make any difference. It just, if you put it someplace else, your hexagon would be turned, but it's still a hexagon. Just be facing a different way if you put the point someplace else. All right, so you're going to take your compass and you're going to open it up. You're going to put the pointy part at the center, and you're going to put the pencil at the edge, or actually it doesn't matter which way it is because you're not doing anything right here. So you could put the pencil at the center or the pointy part at the edge, because all you're trying to do is measure the radius of your circle. Okay? So you're going to set the compass on this point and set the width of the compass to the center of the circle. The compass is now set to the radius of the circle, and that's important. You need to know what the radius of the circle is, because that's going to become the length of the sides of our regular hexagon. And so let's continue through our steps. You're going to make an arc across the circle. This will be the next vertex on the hexagon. Right, so this is point A. Right, we made a mark, right? So we made an arc across the circle, right? And where that arc intersects the circle, we can put a vertex. That's going to be point B. This distance here from A to B is the same as A to O. Right? So AO is congruent to AB. Right? And AO was the radius. Oh, by the way, if I write something down, I want you to write it down too on your diagram, on your notes. Right? So make sure you include a line from the center to the edge showing that that's the radius. And include what I'm writing right here. Right? So AO is the radius of the circle. That's congruent to AB, and AB is a side in the hexagon. All right, so now you're going to move your compass and you're going to draw another arc. All right, so here was A, where we started. Here's where we made B. All right, and so we put the compass, we don't change the spread of the compass at all. We put it on B and we draw another arc. All right, and where the arc intersects the circle, that's point C. It's the third vertex on the hexagon. And you're just going to continue this way until you have all 6 vertices. All right, so we started with A, we put the compass on A, the pointy part, we kept it open to this exact same length as the radius, right? And we drew an arc that made point B. We moved the compass to point B. We didn't change the spread at all. We made another arc, and that gave us point C. We took the compass, we moved it now to point C. We made an arc. Where the arc intersects the circle, that's point D. And at no time have we changed the spread of the compass. We move the compass to point D, we make an arc. Where the arc intersects the circle is point E, and then we move the compass to E, we make an arc. Where the arc intersects the circle, that's point F. And that is the 6 vertices for our hexagon. And actually, we're almost done here. So this is really not a difficult construction. All right, so now we're going to draw a line between each pair of vertices for a total of 6 lines. Right, so the vertices of my hexagon are the purple and the one green line. I just wanted to show you a few things. All right, so now we have a hexagon, a regular hexagon, inscribed inside our circle. All right, so I want you to include in your notes, I want you to go over the lines like I have over here, and then show AO and segment BO on your hexagon diagram. And I want you to note that AB, segment AB is congruent to segment OA. Right? So AB was the side in our hexagon, and OA and OB are radii of our circle. It seems like my diagram just jumped, and I have no idea why. So that's a I don't know why I put radii. Yes, those 2 lines are radii, but the red line is a radius because it's only one. So this is a radius, and this is a radius of the circle. So they have to be congruent. Excuse me. About to cough there. And we use that same measurement to draw the sides of the hexagon. Right? So all of these segment measures are radii of congruent circles, right? Because if we continued when we made our arc and we didn't just stop at the arc, right? We made our whole circle, we'd have a circle, right? And so A, for instance, would be the center of a circle, and it would go through B. And then B would be the center of a circle, and C would be on that circle. And the same thing with D. D would be the center of the circle, right? And E would be on that circle. But if we drew the whole circle instead of just an arc, this would be a really crowded drawing, right? We'd barely be able to see our inscribed hexagon. So that's why we only do the arc, because that's all we need. But that arc is part of a congruent circle. Right, so in your notes, I want you to add that information that's there so you can understand this construction. I also want you to box or highlight or star the information in the box there. So an explanation of the method, as can be seen in the definition of a hexagon, Each side of a regular hexagon is equal to the distance from the center to any vertex. This construction simply sets the compass width to that radius and then steps that length off around the circle to create the 6 vertices of the hexagon. Right? So they're all the exact same distance apart from one another. Let's go through this construction. To save a little time, I already drew the circle. And somehow it moved. So I had it perfect because, see, I can't see the center. See, my center is gone. So I smartly put my compass at the center of my circle, right, and then drew the circle from there. So I put my finger on the point of the compass, and then as I move my finger, the circle moves out, so that I would know where the center was because it's where the compass was. Right? And now, hopefully, and I had it open to the point there, and this is my point A. Right? I just put it over on this side to show you it doesn't make any difference. So hopefully, I have not changed anything, although I really should have oriented the board before I started recording, because obviously things aren't where they're supposed to be. So I put that point there, the center point there, where the point of the compass was, and hopefully my compass just closed a little, but my point is still at the center. Otherwise, we're going to have a really funky construction. But let's hope for the best. All right, so that's this particular length. That's the radii. Oh, and by the way, you have space in your notes to do this along with me. Yay! All right, so you do it with me. All right, so you can just draw your circle. You'll be able to see the center because the point of the compass is going to make a mark. All right, so now you're going to put your compass on the center of the circle and open it so it is the goes to the edge of the circle. All right, and when you move it, you can put a point on your circle. Actually, you can probably do the point right now. All right, so maybe just mark it as you're doing it, just so you know where it is. Or even better, what you should have done actually, I put the point in afterwards because I can't move that compass at all until I start going. Just put the point on it first and then measure. That would probably be the best way. But I had to measure first and then put my point because that's the only way I know where my center is. And let's hope for the best on this, right? That nothing got moved around when I changed the page. All right, so now I put my compass right on point A. I think that's the center of point A. All right, and I didn't change the width at all, and I'm going to make an arc. Right? And that's my second vertice. A is my first, that arc is my second, and I'm going to move the compass. I'm not going to change the spread. And come on, compass, go. And I'm going to make another arc. Right, so I'm just going around the circle, marking off the same length, trying not to change the spread of the compass. Because you can't do that, be careful that you don't change the spread of the compass. Right, and I need to turn this a little bit. So now I've got 3 vertices. Right, so that's where the next one's going to go. 4 vertices. And we're moving our compass. It doesn't matter, by the way, how big your arc is. Or how dark it is, as long as you can see it. Oh, now we get to the interesting part. So I wisely made my circle so nice and large. And I say that sarcastically, that I cannot reach the top. You'd think I'd learn not to do that. Okay, I think I can reach. So this is going to be one nice big arc. No. Come on. No. Can't seem to move it. Huh. Well, now I've got an issue. All right, we'll move it a little bit farther this way. All right, and now we'll try. Yay, there we go. All right, and I'm going to put the point of the compass now on that. There we go. On that point. And again, I can't reach, but we'll just make one really large arc here. It's fine. There we go. All right, and there's the 6th vertice. We'll just leave that up there. All right, so I'm going to mark my vertices, and I'll call this B, and I'll call this C, and I'll call this D, and I'll call this E, and I'll call this one F. And now, because I want straight lines and I can't use a ruler, I'm going to use a line tool. All right, and so A to B, I got to fix that one line there, doesn't hit A. And B to C, and so you'll just use a ruler, C to D, D to E. Oh, that's not in the right spot. E to F, and finally F to A. And let's fix those couple lines that are kind of missed their mark. There we go. And so that's all there is to the regular hexagon. All right, you just measure from your center to your edge. You put a point at your edge. You draw a circle. But assuming you have a circle, then you put a point on the edge of your circle, right? And you measure from the center to the edge. You keep that same compass length, right? And you go, you put the compass on the point, you make an arc, and you just keep moving it around, right? Making the arcs. Right, and you can see here, it didn't matter where A is located. I have the exact same hexagon. Mine's just turned a little bit. All right, one last thing to look at for hexagons. Because a hexagon has an even number of sides, in a regular hexagon, opposite sides are parallel. Right? So if we look back here at my hexagon, right, the opposite sides would have been parallel. So that means DC and AF, although boy, that's kind of missing the point right there, isn't it? Yeah, that looks better. And AB is parallel to DF, and CB is parallel to EF. So you notice that when I have a different pair of parallel lines, I have to use a different number of those little arrows. Right? So some information about that particular hexagon. In a regular hexagon, the radius equals the side length. That is, a line from the center to any vertex will have the same length as any side. Because of this, a regular hexagon can be thought of as being made of 6 equilateral triangles. And finally, the nuts and bolts of hexagons. Most nuts and bolt heads are made in the shape of a hexagon. Because a hexagon has 3 pairs of parallel faces, a wrench can be placed over any pair. In a confined space, the wrench can be turned 60 degrees, the exterior angle of a hexagon, and then the wrench repositioned on the next pair of sides. Doing this repeatedly will tighten the nut. In this way, you do not need room to rotate the entire wrench a full circle, right? Because it's going to be in, usually in a little confined place. Right? It wouldn't work as well with a square, right? Because you'd have to rotate 90 degrees. Here I only have to rotate 60 degrees. And the other angle, the angle in the hexagon, all of these angles in our hexagon are 120 degrees, right? Because together, those two angles make a straight angle. Well, thanks for watching this podcast. And if you have any questions, let me know. But have a great day.